Hello students, let us now start with Fresnel's biprism experiment. So here is the first question. In a biprism experiment, the bandwidth is like 0.4 mm. When the eyepiece is at a distance of 1 meter from the slit, and if the eyepiece is now moved through a distance of 25 centimeter towards the biprism without changing any other arrangement, then the change in fringe width is what? They're asking change in fringe width. They're not asking the new fringe width. They're asking the change in fringe width. So you have to subtract the new one with the previous one, and then you would get the answer. So here are the options. Option A is like 0.1 mm. Option B is like 0.01. Then option C is like 0.001, and option D is like 0.0001 mm. How would be the solution? We would be using the basic formula which we get from biprism, that is x equals to lambda d by d. So my x1 would be lambda d1 by d, and x2 would be lambda d2 by d. Just as in, only changing parameter is the distance of screen and the slit. So we would be dividing this, and I would be getting x2 upon x1 is nothing but equals to d2 by d1. And d2, what is d2? D2 is nothing but reduced by 25 centimeter. The previous D was nothing but 1 meter, that is 100 centimeter. So if 25 centimeter is reduced from 100, it would be 75, and it would be like 75 upon 100. And we know already what is x1 is. x1 is 0.4. So it would be just coming to the RHS, and it would be getting multiplied, and we would be getting x2 is nothing but 0.3 mm. Now, this is the new one. The previous one was 0.4. So I just want to find out the change in fringe, that is delta x. And delta x would be nothing but equals to x1 minus x2. What is x1? 0.4. What is x2? 0.3. So this is going to be the answer, 0.1 mm. So students, this was the first question. Let us move to the next one. The next question would be like, in the biprism experiment, if the image produced by convex lens in the two positions between the biprism and the eyepiece are 4.5 mm and 2 mm apart, that is D1 and D2 are given in this question. And what we just need to learn is, we just need to find out the distance between two virtual sources, that is the small d part. So we already know the formula for it. Let us go to the options. Option A is like 2 mm, option B is like 3 mm, C is like 4 mm, and D is like 5 mm. Now, what we should do? We have basic formula for small d. Small d is nothing but what? Small d is under root of d1, d2. And d1 is given 4.5, d2 is given 2. Just by substituting it, it would be like 4.5 into 2 would be nothing but 9. And square root of 9 is nothing but 3 mm. So the option looks like option B. So there is my answer, option B, 3 mm. So this was the second question. Let's move on, and the next question is like, in Fresnel's biprism experiment, the second dark band is at a distance of 1 mm from the central bright band, and if the distance between source and the screen, that is capital D, is 1 meter, and the slit width is 0.9 mm, then the wavelength of light used is what, is the question. So the options are like 6,000 angstrom, B is like 7,000, C is like 5,000 angstrom, and D is like 5,500 angstrom. So I just need to check out with wavelength. I will be going with the same formula, but this is a dark band, right students? So for dark band, the condition for part difference is like 2m minus 1 upon 2x. So what is 2m? M is here 2. Second dark band, so M stands for 2. So it will be 2 into 2 minus 1, it would be getting as 3. So that becomes 3 by 2x is nothing but equals to 1 mm. So students, I will be getting value of x here. So it will be like x is nothing but the reciprocal of 3 by 2, that is becomes 2 by 3. So x is 2 by 3 mm, and then lambda goes simple because lambda is xd by d. So I'm just substituting value of x as 2 by 3. We already know what is small d here, and we also know what is capital D here. So all the things are in meters, so I would be getting lambda in meters, and I would convert it into angstrom unit. So there would be my answer. Lambda is 6,000 angstrom unit. So this looks like in the option A. So the answer to this question is option A. So students, this was from this module. That's it. Thank you.